Hi guys, welcome back to In Case of Econ Struggles. Welcome to another macro struggle. Today we are finishing up solving the Arrow-Debreu equilibrium. This is part 2. In the previous video, we reviewed the Arrow-Debreu equilibrium setup and solved for the Euler equation. We also saw that there was perfect consumption smoothing. So we are going to quickly review those results, and then we are going to find the prices, the equilibrium prices. Then we are going to use the budget constraint to find the allocation for Bill. And then we are going to use market clearing to find the allocation for Dave, and then we will be done. Timestamps are below if you'd like to jump around, but let's go ahead and get right into it. So remember, we've got Bill and Dave. These are their endowments. This is their utility maximization problem. We have this market clearing condition. This is the Arrow-Debreu market where we're trading promises to pay. This was our strategy. So we have set up the Lagrangian. We have taken the 4 representative first order conditions. Then we have combined those first order conditions together to find the Euler equation. And now we're into step 4, where we're going to use market clearing and the budget constraint to solve for these allocations. So here are the first order conditions. We set it up this way, and we found, either from looking at this Euler equation or from using market clearing, we found that both Bill and Dave consume the same amount of coconuts every day throughout their entire infinite lifetime. Now, notice if I just take this guy right here and I include the betas and the prices. So let's take this down and let's maybe put this right here. Take away this circle in this box. Okay, well, we can simplify this a little bit because this will say that 1 over beta is equal to CT plus 1B over CTB, which is equal to PT over PT plus 1. Well, this is just 1, as we saw before, because Bill consumes the same number of coconuts every day. So this means that beta is equal to PT plus 1 over PT. And that is a super useful result, which we're going to push a little further as we think about, well, what is PT in general? Well, we know that we've normalized P0 to be equal to 1. We also know that PT plus 1 over PT is equal to beta, which means that P1 must be equal to beta. What is P2? P2 is just P2 over P1 times P1 over P0. Both of those are just beta, so we get beta squared. If we do P3, well, P3 is just P3 over P2 times P2 over P1 times P1 over P0, which is equal to beta to the third, which means that PT is just equal to beta to the t. So now we have everything we need to put this into the budget constraint and solve for those allocations. So we have the relationship of everyone's consumption to their consumption next period. We know prices. We haven't used the budget constraint, but we need an actual allocation. So this is where we are going next. So I know that Bill gets 2 and even periods because remember, this is t equals 0. This is period 1, 2, 3, 4, 5, ... So what is Bill's budget constraint? Well, it's the infinite sum from t equals 0 to infinity of PT CT. Well, PT is just beta to the t. And we know that CT is just some number that Bill consumes in period 0, which is equal to the same number that he consumes in every period. And we know that this is equal to his endowment times the price. So this is equal to 2 beta 0 plus 0 plus 2 beta to the second plus 0 plus ... So we also know that the sum from t equals 0 to infinity of beta to the t is equal to 1 over 1 minus beta, since beta is less than 1. So this left-hand side is really just C0b over 1 minus beta. This right-hand side, we can just rewrite as the infinite sum from t equals 0 to infinity of 2b to the 2t, which means that this is just C0b over 1 minus beta is equal to, I pull the 2 out. This is beta to the 2t, which means it's 1 minus beta squared, okay, which means that Bill's consumption in period 0 is just 2 times 1 minus beta. I'm just going to expand the 1 minus beta squared into 1 plus beta, 1 minus beta, which means that Bill's consumption in every period for his infinite life is 2 over 1 plus beta. Now I can use market clearing because I know there's 2 coconuts in every period. And now that I know that Bill eats 2 over 1 plus beta of them, Dave will eat whatever's left. So now I have C0B plus C0D is equal to 2, which means that the number of coconuts that Dave is going to eat is going to be 2 minus 2 over 1 plus beta, which means that Dave's coconuts in every period are going to be 2 plus 2 beta minus 2 over 1 plus beta, which means that Dave's number of coconuts is going to be 2 beta over 1 plus beta. Now it's really easy to be like, cool, we're done. But remember, we're solving for a competitive equilibrium. So we need to put it all back together. The Arrow-Debreu equilibrium is the allocation where Bill eats 2 over 1 plus beta coconuts and Dave equals 2 beta over 1 plus beta coconuts for every period t from 0 to infinity, given the prices where the p in each period or the pt is equal to beta to the t. And we know we have market clearing. We know we've satisfied our utility maximization problem. So now we are done. Hopefully these 3 videos give you a better idea of how to solve an Arrow-Debreu equilibrium and how to set it up. If they did, make sure to like and subscribe, and we will see you next time for another case of Econ struggles.